Hello, so welcome again. Okay, so this part is mainly to explain and to remind you guys of the substituents that you need to remember. Okay, so we're going to be representing the parent chain in purple. Okay, so that you can tell what is the difference among them. Okay, so first we have our alkane substituents. Okay, so if you notice here, extending from the parent chain as a Y. Okay, and that's going to be our isopropyl. Okay, since this color doesn't show very well, I'm gonna switch to green. So isopropyl. All right, now if it extends and also looks like a Y, it kind of looks like isopropyl, but it has one more carbon on a branch on a side of the Y. Okay, we have 4 carbons, so it's a butyl. Okay, but since it's attached from the second one, so this is going to be called sec-butyl. Okay. Alrighty. So now this, if you notice, 1, 2, 3, 4, 1, 2, 3, 4 attached from the second, and from the second, this is going to be another one of those sec-butyls. So it's also called sec-butyl. Okay. Now we have the isopropyl. Okay. Here we have another one that looks almost like that. Okay. It also is a Y, but it has one extra carbon on its stem. Okay, so this is going to be called isobutyl. How can you tell? Well, but means 4 carbons, so 1, 2, 3, 4 carbons. Okay, now we go to the aromatics. When you have an aromatic, okay, extending directly from the chain, nothing else, this is going to be called a phenyl group. Okay, when you have something very similar to that, but you have an extra carbon over here, okay, this is going to be called a benzyl group. Okay, now another special chain that you will encounter if it's a cycle. Okay, but that cycle is extending from the parent chain, so not the actual parent chain. So here you will take into account these 3 carbons, or the carbons that cycle is made of, and you're going to call that cyclo. Okay, in this case you have 3 carbons, so it will be prop. Since it is a substituent, not longer a cyclopropane, okay, making it a substituent, makes this a cyclopropyl. Okay, finally, okay, all right, our last ramifications. Okay, so here we have an example of an ether. How do we call an ether that is a ramification? Well, you need to cover up the oxygen. Okay, and you count how many carbons you have after that. 1, 2. Okay, so 1, 2 carbons, so that is an F. Okay, and then this oxygen right here, oxy, ethoxy. Okay, could be methoxy, 1 carbon, then followed by an oxygen, etc. Okay, our final version, okay, it's our alkyl halide, which is, in this case, a fluorine group, which would make this a fluoro ramification. Now, which part of the name are we going to take into account for each of these, okay, when we organize these alphabetically? For your isos, it's always going to be your I. For the sec-butyl, okay, it's always going to be the B. Okay, now for the rest, okay, we have phenyl, the P, benzyl, the B, fluoro, F, ethoxy, E. Okay, now here, cyclopropyl. Okay, the part that we take into account for alphabetical arrangement is the part that tells you how many carbons you are dealing with. The cyclo does not tell you about how many you have, the propyl does. So this part is the one that we will have to take into account. Okay, so the P in this one. Okay, so be very careful with these, okay, and you will see them quite often.